Hello and welcome to week 6 of CNET56. I'm going to share my screen real quick. All right, so this week we are going to begin our investigation of routers. So let me talk about that for just a little bit. All right, so this is chapter 4 of the textbook. All right, so chapter 4 is all about routers. So we're going to look at TCP/IP core protocols, look at how the message is formed, and look at some utilities. So as we've already seen in our discussions and labs, there's a suite of protocols. So what that means is that they're not all identical. They're different protocols are designed for different functions. So for example, when we use the ping utility, which we've used in almost every single lab so far, it sends the ICMP echo request, and then the other end sends an ICMP echo reply. And then there's TCP, the transmission control protocols, and the UDP, the uniform datagram protocol, and so forth. So there's a lot of things going on. Now, most of this information is in the transport layer. Okay, so most of the time, all that is going to occur here. Now we know layer 1 is where we are physically connected. Layer 2 is where we have our MAC address in. Layer 3 is where our network layer, and then layer 4 is where our transport layer occurs. Okay, so and then layer 5, 6, and 7 is the data and the information is sent. So if you were to look at each layer, when it goes from layer 1 to layer 2, it's voltage at layer 1, it's a frame in layer 2, it's a packet in layer 3, then it's some sort of port and a packet, which is known as a segment. Okay, so that will be at layer 4. Then 5, 6, 7 is just data. All right, so TCP, as you could probably guess with the transmission control protocol, operates in the transport layer, which is layer 4. TCP is connection oriented, which means it will perform a 3-way handshake. So what that 3-way handshake does is it establishes a formal communication channel between the sender and the receiver. And in this week's lab, you're going to look at that using Wireshark. All right. So the segment contains the data, and then it's going to have the information in here, like what port is it starting from, what port is it going to, and then it has the acknowledgement and various other resources in there. All right, so the 3-way handshake is a 3-step process where step 1, it requests a connection with the synchronization. A response to the request is from the other end, comes back with its own synchronization, and then an acknowledgement to the sender's synchronization. And then step 3, it goes back the other direction with acknowledgement. Once that happens, then the data is sent across. Now, the sequence number, which is in the synchronization packet, will be increased by the number of bits included in the segment. And that will confirm that the correct length of the message was received. And then when everything's done, it closes the session with a three-way handshake, but instead of synchronization, it uses a finish. So fin, ack, and then ack. All right. So just like the sin, ack for their three-way handshake. Now, UDP is an unreliable connectionless protocol. So TCP is a connection-oriented protocol, which means it guarantees delivery, whereas UDP is not connection-oriented, it's connectionless. So it just attempts to deliver the information one time, and that's it. If you get it, you get it. If you don't, well, then you need to do something about it. Okay, so like our streaming services will use UDP because it's faster, because there's no error checking, there's no flow control, there's no connection guarantee. It's just like, boom, here it is. If you get it, you get it. If you don't, well, then you miss part of the whatever is streaming. So live audio or video transmission over the internet is a common user datagram protocol application. Okay, then IP. Now we've spent a lot of time so far talking about IP addresses. IP by itself is just the framework or the mechanism by which TCP IP is allowed to transfer. Okay, so IP depends on the TCP to guarantee delivery, to make sure everything gets there. All right. So here's a packet for IP version 4. Now, IP version 6, we're going to come back to this in another lecture, but it's a different format than IP version 4, and it has a much bigger address space. So instead of 2 to the 32nd power, right, because IP version 4 is the 32-bit address scheme, IP version 6 is 128, so it's 2 to the 128th power. So 2 to the 32nd is around 4 billion. 2 to the 128th is a number, and I'm not making this up. It's really called 340 undecillion, which is a monstrously large number. All right. And then the ICMP protocol is used for testing. So like our ping request uses ICMP, and we'll see that in Wireshark as well. So you'll ping a address and you'll filter Wireshark for ICMP, and you'll see the echo request and then the echo reply. All right. And there's some other protocols in here, ARP, which is the address resolution protocol, the neighbor discovery protocol, which is used by our routers to advertise and share their routing information. And then we'll have a brief look at Ethernet. Now, if you remember from last week, and let me open Wireshark real quick. So some of you that looked around Wireshark in the lab, so let me get this over here. So here's our Wireshark. And to start a capture, we want to select our Ethernet, double click it, and it will start to gather all kinds of information. So I'm not doing anything on this other than I'm on Canvas and recording this, but you can see there's all kinds of activity. So I'm going to stop this. And this Ethernet is the most important data link layer standard. So if we come over here, this top one shows us the frame, and then the next one shows us what type of frame is it. And the most common frame type is Ethernet 2. Okay, so that's the current standard. And the Ethernet has the ability, this is what sends all of our data. So with Ethernet, it takes the data and it pads it up to 1500 bytes. And then it tells us what the frame type is. And then it sends a source, destination, and the rest of the information and it sends it across our network. So if we were to look at this in Wireshark, we can see this is where the data in this area is converted into a frame, which is Ethernet 2, and we can see the destination MAC address and the source MAC address, and then it says what type of data is inside this frame. Well, it's IP version 4. And then the next layer here is the IP version 4 information, then finally the TCP information, okay? So that is in our Ethernet frame. So here's a little knowledge check. Which protocol's header includes the source MAC address? And that's going to be the Ethernet frame, right? Because UDP doesn't have anything to do with that's data is encapsulated in UDP connectionless. IP is the IP address. TCP is connection oriented, and that's all. UDP, IP, and TCP is all happening at layer 3, whereas Ethernet is at layer 2, right? The frame, and that's of course where we talk about MAC addresses. All right, so there are also some information in this week's lecture about encryption protocols. Now, with the various protocols there, I'm going to leave that for you to look at. Remote access protocols, you're going to look at those. And then the last thing we're going to cover this week, and then we'll finish this information next week about routers, and I'll make another video for that, is with the VPN. Now, the VPN is a network that tunnels through another network. So, for example, we have our internet, which is considered an unsecure network. And then if we want to VPN into, say, our workplace, say we're doing remote work from home, we will establish the VPN session, and then that data is tunneled through the VPN inside a channel or a pipe inside the internet, and it's secured with those encryption protocols. Okay, now we can have different models. We can have a site-to-site VPN where our site and your site, say we have an office here in Walnut and another office in, say, Tempe, Arizona, and we want all the data that's sent in between those two sites to be secure, we would use a site-to-site VPN. The client to site, so here we have Mount SAC, and here we have our home user. They would use a client to site VPN, and then a host to host VPN is where one system connects to another system, host to host. All right, so there's some protocols with our VPN technology, L2TP, GRE, and OpenVPN. The L2TP is very common, and it's does a good job of securing everything. It's fairly fast, so you'll see that one a lot in a lot of your VPNs. Although some VPN manufacturers, depending on who it is, say it's from a Dell VPN appliance, they may have a proprietary or a preferred protocol that they'll use. So this really depends on what you're doing. Okay, so here's the frame for the VPN network, and then some more protocols for that. All right, so I'm going to stop right there with the PowerPoint, and I am going to show you. I'm going to demo the Wireshark part of the lab, this week's lab. Let me open that real quick. All right, so here's the lab. Let me make this a little bit bigger. What if I did something here? All right, so let me make this a little bit bigger so you can read it. So first thing you're gonna do is open Wireshark and do a three-way handshake. So what you're gonna do is read all that stuff, open Wireshark, start Ethernet, open up Chrome, and then make Wireshark full screen. And what you'll notice is, first thing I want you to do is get the IP address of mountsac.edu. And once you get that, you are going to open that IP. So you're going to go to mountsac.edu with this Wireshark capturing, then close Wireshark, okay? And then I want you to tell me what is the IP address of mountsac.edu, which you can find that in a bunch of different ways. So pick one and then show me how you did it. Save it as a file lab61 and paste it right here in the lab. Okay, and then in the filter area, you're going to type in ip.addr equals, and then whatever the IP address you got for mountsac.edu. Okay, so whatever address you got here, that's the address you're going to type in here, and it has to be the IP address. And then I want you to find the first packet with the CNET sequence, and then you're going to right click on it and select follow TCP stream, and then you're going to click on this filter out this stream. And then you're going to go into the filter and you're going to remove this exclamation point, because we don't want it to be not this IP stream, we want it to include it. So this is the easiest way to get that, is to first filter it out and then remove it so it filters it in. And then you should see the three-way handshake. And then I want you to take a screenshot of yours and paste it here, okay? And then click on the first packet, which should be the SYN, and I want you to show me the sequence number. And then you're going to clear the display, and then you're going to do some ping work in Wireshark, right? So I'm going to leave that for you there. Okay, but I do want to show you getting started with packet tracer. So I'm going to close Wireshark and open up my packet tracer. All right, so now we're over here in packet tracer, and we want to build this topology. So we're just going to get a laptop, a PC, and then a 2960 switch. So again, to get the end device or the laptop, you go to end devices, and we're going to select a PC, and then we're going to select a laptop, and then we're going to select a switch. So if I come over here to switch, and I want to 2940 or 2960, okay? And then I want to connect it. This one is a console cable. This one is a patch cable. All right, so I'm going to come in here and I'm going to click on my connectors, and this blue one is a console cable. So I select that, and then I click on the laptop. That goes to the RS-232 port on the laptop, and it goes to the console port on the switch. Then I'm going to select a straight through cable, and I'm going to put that on the Ethernet port of the PC and switch port 0 of the switch. All right. So let me make this a little bit bigger. And you can do Control-I, we'll make that as big as it'll go. All right, so now that I have this connected, I am going to give the IP address, the PC of 192.168.100.100 with subnet mask at 255.255.255.0. So to do that again, you just come in here. Okay, and if you get that error, just hit OK, and then it will go in. And again, we go to config or desktop IP config, and this is 192.168.100.100, and the subnet mask 255.255.255.0. All right, and it doesn't say anything about default gateway or any other function here. So I'm just going to click off of that. And now if you mouse over this, it will tell you that it has an IP address. All right. So next thing I want to do, and here's how you get there. But the next thing I want to do is go into the terminal on the laptop. All right. And to do that, I just click on the laptop, desktop, and I'm going to click terminal and just select these default values. All right. And then once that connects, you notice if I hit enter, it gives me a connection to this switch. Okay, so we're going to use this to configure our switch. Now there's some modes here that I talk about, the user exec mode, which has the prompt. So if you look at the prompt, it'll tell you what mode you're in. So you can see on this connection, I'm in the user exec mode. If I type enable, then I'm in the privileged exec mode. If I type configuration terminal, now I'm in the global configuration. Okay, so COMP2, you can shorten that. For whatever reason, it doesn't like that spelled out. All right, so now I'm in there. And then to get out of there, you just type exit, and then exit, and then you go back into your different modes. All right, so what we're going to do, so wherever you see a screenshot like this, if you just go to the next one and type that, you'll see that we're going to go there. So the first thing we're going to do, oh, it's configure terminal, not configuration terminal. So let's go to configure and conf terminal, and let's change the host name to local switch. So if I come back over here and I'm going to type enable, and then configure terminal, and then local switch. All right, so now I just did this here. And then I want to change the banner message of the day. So to do that, I'm going to type banner MOTD, the pound character, enter the text, and then I will put a pound at the end and it will end it. Okay, so let me just bring this where it's clear. So I'm going to go banner MOTD pound, and then I'm going to say unauthorized access is forbidden, and end it with the pound, and then it saves it. Okay. Then I'm going to set up the password to get into privilege mode. That way, if anybody gets access to our switch, they're not going to be able to get into it unless they know our password. So now I'm going to type enable secret Cisco. Okay. And then I'm going to say to encrypt that password so that if anybody looks at my configuration, they won't be able to find it. Okay. So then you're just going to keep going down this lab and type in all of the commands that you see that I took screenshots of. All right. And then when you're done, you're going to telnet into the router. So once you have that set up, you're going to have to telnet in and show me the IP configuration for the PC, a login from the telnet from the PC to the switch, and then how you change to privilege exec within telnet from the PC to the switch. So include those screenshots and you'll be good to go there. All right, so that's this week's lecture and lab. And if you have any questions, reach out to me. And also during the lab, if you have any questions, just let me know and I'll help you there. All right, see you this week in lab. Bye.